Well, welcome to our fourth weekly wrap-up. At this stage, we have now finished all our nomenclature. We can look at a molecule, something that there are many different types of, and we should be able to start to pick out the different functional groups that are in organic structures, like this one over here, which actually hasn't been made before. It's been isolated from some, I don't know, seed sponge or something like that. It's called allotoketol B, and number A has actually just been made. It was reported in the Journal of the American Chemical Society this year, and it's slightly different from this, but not so different. Now, what we need to be able to do with this would be a typical question in one of your tests and exams. You would be asked something along the lines of, you would be expected to be able to give the molecular formula. You would typically be asked to indicate how many pi electrons there are, whether there are any conjugated double bonds, and various things like that. So what I'm going to do is I'm going to ask you to just work out the molecular formula from the structure, and then I'm also going to ask you to look at the structure and circle and identify as many functional groups as you can pick up from what we've learned, and tell me what they are. And then once you've done that, start the video again, and let's see if you got these things correct. All right, so the molecular formula is going to be quite complicated because there are a lot of carbons present, and we've got to be very careful to make sure we count them all up correctly. So when we write out our molecular formula, it's going to be carbon, hydrogen, and we've only got oxygens. There's no nitrogen. So that's the order that they're going to be in. The oxygen's easier, 1, 2, 3, 4, 5, 6. The carbons and the hydrogens are going to be quite tough. So we go through it carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I'm hoping this is right. You can write into me and tell me if I'm wrong, if I've missed something. 3 hydrogens there. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. All right, I'm pretty sure I've made a mistake. In your test and exam, you're going to have to look very carefully and double check all your work. What I really want to get to with this is looking at the different functional groups. So this would have been one functional group. This is an alcohol, and it is a primary alcohol. Okay, primary alcohol. Make sure that you got that right. There are lots of alkenes around. All right, this is a functional group. It's just an alkene. All right, there's another one over there. There's another one over there. There's another one over there. This is a ketone. It's not a primary ketone or secondary ketone, it's just a ketone. You get a full mark for that. This, it's a half mark for the primary and a half mark for the alcohol. Half, if you don't have the primary there, you will lose a half a mark there. Did you get this? This functional group over here is an ester. Right, that's one that we've learned recently. And then the difficult one, which a lot of people miss. Did you get this middle bit over here? This, it looks a bit weird, but it's a carbon singly bonded to 2 oxygens, which themselves are bonded to other carbons. This is an acetal, and it's very difficult. It's easy for people to miss this, so watch out for this. We see it's probably one of the harder groups for you guys to recognize. Okay, so in the course, the last 3 lectures that we've had, we've basically just gone through all the different functional groups. We've covered now our single, triple, and double bonds in terms of carbon-carbon bonds. We've looked at alcohols, we've looked at amines, at thiols, at the aldehydes, acetals, carboxylic acids, esters, amides, and nitriles. We've covered all of those. They're very quickly covered in your textbook. You should be able to identify all of those now. And I just want to do just 2 examples. We could do examples ad nauseum. I just want to do 2 examples that we can just use to practice what we're doing, and yeah, and we'll continue to look at things as we go through the course. So, and you'll see this come up in your tests and your tutorials. So let's just try and draw out 4-bromo, 3-mercapto, benzonitrile. Right, need to have a dash there. All right, pause it now and just draw out 4-bromo, 3-mercapto, benzonitrile. Okay, benzonitrile. Benz means that it must have been something that looks like this. It's an aromatic ring. There's a nitrile group on, and we learned that the nitrile group is CN. The nitrile group must be on position 1. We start numbering from there. Whether we go clockwise or anti-clockwise doesn't matter, but that's 1, that's 2, that's 3. 3 is the mercapto group. Mercapto is an SH, it's a thiol. It's the substituent name, all right, for an SH. A thiol is mercapto, and on position 4, there's a bromine. Right. Hopefully that one wasn't too hard. I have noticed in the classes that you guys are doing very well in terms of your naming, so I'm hoping that that was okay. All right, so now one that's a lot harder, but again, just this is probably almost harder than you would expect to get in an exam, unless I was putting this maybe as a bonus mark or something. But this one, it's trans, ethyl. There's a space here, 5-amino, 2-isopropyl, hex 3-eno-8. All right, have a look at that. Pause, try and draw this out, and then come back and we'll see if we can answer that. All right. The first thing to identify is, if you notice this, it's an O8. It means that we've got an ester functionality, all right? Something along those lines. This helps us with this part over here. We know that it's some sort of ethyl ester, all right? That part says it's an ethyl ester. The ethyl refers to what's connected to the oxygen over there. So, and the other thing that we notice is that it's a hex. The parent is hex, which means 6 carbon atoms. So if we draw out 6 carbon atoms, 1, 2, 3, 4, 5, 6, we put our ester group on that position, and on the oxygen we have an ethyl. Don't worry about the trans yet. It'll become clear as we draw this out. We put the ethyl group over there. So this is ethyl hexanoate, and we've got our backbone in place. We've got this part, we've got this part has been done, that's been done, and that's been done over there. We start numbering this chain, all right, from the ester oxygen. That's the parent. So we go 1, 2, 3, 4, 5, and 6. And we now start filling in all the rest. On position 5, we have an amino group. So there, it's an NH2. On position 2, we've got an isopropyl group. All right, here's position 2. This is an isopropyl group. Check, we've done that. On position 3, we've got an ene, a double bond. So between 3 and 4, we must have a double bond. And now, because we've got a double bond, this information over here starts to make sense. And the trans means this double bond must be trans, or 2 substituents must be on the opposite sides of each other to the same substituent. Actually, we see how we've drawn it out has been the correct answer. So the correct answer already, if we divide this in half, the double bond there, we see that we have a hydrogen there and we have a hydrogen there. They are on opposite sides of the line that we drew through that. And so this is already trans. What we drew out, our first attempt, was the trans. If we were expected to do the cis, all we would do is we just redraw out this whole thing again. Right, just do this quickly. Put the double bond there, and we would switch things around. We want a hydrogen going up there, so this set of hydrogen down here, we'd put this, which would be the NH2. It would look something like that. This would have been the cis version if we had been asked to draw it. All right, good. Cheers.